Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 78. For the region shown, compute the moment of inertia with respect to the centroidal y-axis in two ways. So let's solve this into two ways. And the first way is by direct transferring of moment of inertia of each to the centroidal uh, axis. And the second way is computing the moment of inertia of the region with respect to the y-axis and apply Iy equals Igy plus area barred x or xg square. So for our solution, let's have uh, this rectangle. So let's have this triangle here, which is 80 minus 50, so 30 mm. The area of the rectangle, by the way, is 90. 40 plus 50 is 90 by 80, so 7,200. So since we divide it, we have to subtract this area, which is 1/2 of 90 times 30, and it is negative 1350 mm square. The area of the quarter circle is pi over 450 square. So that would be negative 625 pi. For the location of the centroid, this is the centroid of the rectangle, which is 1/2 of 90 from the y-axis, so that's 45 mm. The centroid of the triangle is 2/3 of 90, so that's 60 mm. I'm not showing it here, I'm just mentioning, and I hope you can listen and remember. While this is the centroid of the quarter circle, from here is 4r over 3 pi, 4 times 50 divided by 3 pi. This is the centroid of the entire region, and the distance from the y-axis is denoted by xg. So this is 4 times 50 over 3 pi, and that is 21.221. Therefore, its distance from the y-axis is 90 minus 21.221, and that is 68.779 mm. So area is equal to 7,200, so that's xg, minus 1350 minus 625 pi. So the area is equal to 3886.5 mm. Then by Varignon's theorem, area times xg equals area of rectangle 7,200 times 45, as mentioned earlier, plus negative 1350 times 2/3 of 90, so 60 mm, then minus 625 pi times 68.779. So 3886.5 times xg equals 7,200 times 45 minus 1350 times 60, then minus 625 pi times 68.779. So solving for xg is equal to 27.776 mm. Now we transfer the moment of inertia of each element with respect to the centroidal axis. So for Igy, it is moment of inertia of rectangle, which is 90 cube times 80 over 12 plus 7,200, then quantity 45 minus xt, quantity 45 minus 27.776 square. For this triangle here, with respect to the centroidal y-axis, is 90 cube times 30 over 36 plus area 1350, then distance 60 minus 27.776 square. Then for this quarter circle, the moment of inertia with respect to this centroidal y-axis is so minus 0.0548850 to the fourth plus 625 pi times quantity 68.779 minus 27.776 square. So expressing the answer in scientific notation times 10 to the 6. So individually, IGY equals 6.996 minus 2.0093 minus 3.6441 times 10 to the 6. So from there, we can solve IGY, or the centroidal moment of inertia, with respect to the y-axis. So here, respect to this axis here, 1.343 times 10 to the 6 mm to the fourth. Then the other way, so that we can verify that that is correct, we compute for IY first, then equate IY as IGY plus area xg square. For the moment of inertia of a rectangle with respect to the y-axis, which happens where this 80 mm coincides with the y-axis, it is just 90 cube times 80 over 3. So IY equals 90 cube times 80 over 3 for this rectangle. For this triangle here, we have a direct formula for that. So minus 90 cube times 30 over 4 with respect to this vertex triangle. Then if you cannot remember this, then apply transfer formula, just like 90 cube times 30 over 36 plus 1350 times 60 square if you want. It will give us the same results. Then for this quarter circle, we have to transfer it. So minus 0.05488 times radius to the fourth. So 0.05488 times 50 to the fourth plus 625 pi times 68.779 square. So it is now transferred on the y-axis. So computing IY equals 4.341 times 10 to the 6 mm to the fourth. Then equate to IY equals IGY plus area xg square, where area is 3886.5 and xg is 27.776 mm. So 4.341 times 10 to the 6 equals IGY plus 3886.5 times 27.776 quantity square. So from there, we can solve for IGY, and we expect that's the answer also. So IGY equals 1.343 times 10 to the 6 mm to the fourth. Level 79, determine the polar moment of inertia about point O of the shaded area shown. So here's the given figure, and for our solution, let's introduce axis, call this x prime. By the way, that's our differential element area, and the distance from O is r. And let's introduce this as our x and y axis. So this is x prime and y prime axis, so that IO, which is Ix plus Iy, is also equal to Ix prime, because the distance is the same about O, Ix prime plus Iy prime. So the distance from here to there is 160 sine of 45, and that is 80 square root of 2. This is the centroid of the semicircle, and this is the centroid of this rectangle here, which is inclined but parallel to, the dimensions are parallel to the x prime and y prime axis. And this is the centroid of the semicircle, and the distance from the center of the semicircle is 4r, 4 times 30 divided by 3 pi, and that is 40 over pi mm. And of course, the distance of the centroid from the right leg is 1/2 of 20, so 10 mm. So this is again 160 cosine of 45, or 160 sine of 45, and that is 80 square root of 2 mm. Likewise, this distance, which is the same as this, is also 80 square root of 2 mm, or because the angle is 45, this is 45, this is 160 mm, therefore this is also 45 degrees. So 100 60 cosine of 45 is 80 square root of 2 mm. So IO equals IX plus IY, which is also equal to IX prime plus IY prime, because of the fact that the distance of this differential element from O is, we have the same O here, is the same. So if we establish axes such as X prime and Y prime axis, so IO is the same as IX plus IY or IX prime plus IY prime. So the moment of inertia with respect to the X prime axis first is we have two right triangles, and this axis X prime happens to be coincident with one of the legs, which is 80 square root of 2. Anyway, the height is still 80 square root of 2. And therefore, it is 2 times 80 square root of 2 times 80 square root of 2 quantity cube over 12 with respect to the base, remember? So IX prime equals, for the two triangles, 2 times 80 square root of 2 times 80 square root of 2 cube over 12. So that's for the two triangles with respect to the X prime axis. Now we subtract the moment of inertia of this rectangle with respect to this X prime axis, and this X prime axis happens to be the centroidal axis of this rectangle. Therefore, we subtract moment of inertia of rectangle with respect to the centroidal axis, 20 times 60 cube over 12. So 20 times 60 cube over 12. Then we subtract the moment of inertia of this semicircle with respect to this axis here, and we just treat it as two quarter circles, right? Although this is the centroid, but with respect to this axis, it's like quarter circle with respect to this axis and another quarter circle with respect to that axis. And therefore, the formula is pi reduced to the fourth over 8. So minus pi 30 to the fourth over 8. So computing for our IX prime in scientific notation, so the first is 27.307, the second is 0.36, the third is is 0.31809, then times 10 to the 6. So IX prime is equal to 26.629 times 10 to the 6 mm to the fourth. Then likewise for IY prime, we have two triangles with respect to this vertex here, and the formula is this dimension cube times 80 square root of 2, this dimension, over 4, then times 2. So IY prime is 2 times 80 square root of 2 quantity cube times 80 square root of 2 over 4. Remember, moment of inertia, but right triangle or triangle with respect to the vertex. Then we subtract the moment of inertia of this rectangle. So it's far, so this is the centroidal axis parallel to the y prime axis. So we have to transfer it here. And the moment of inertia with respect to this axis is 20 cube times 60 over 12 plus area, which is 20 times 60, distance quantity squared. The distance of that centroid from the y prime axis is quantity 80 square root of 2 minus 10, because this is half of 20, so minus 10. So minus 20 cube times 60 over 12 plus area 20 times 60 times quantity 80 square root of 2 minus 10 square. So again, minus 10 because that's 10, half of 20. Then for this semicircle, the moment of inertia with respect to this centroidal axis parallel to y prime is now 0.10976 reduced to the fourth, which is 30 to the fourth, 0.10976 30 to the fourth, plus area. Area is pi over 2, 30 square, then distance square. So the distance of its centroid from here is 80 square root of 2 minus 20 minus 40 over pi, then quantity square. So minus 0.1097630 to the fourth plus pi 30 square over 2 area, then distance 80 square root of 2 minus 20 minus 40 over pi quantity square. So simplifying and computing each, IY prime is 81.92 minus 12.805 minus 9.2285 times 10 to the 6. Combining IY prime equals 59.8865 times 10 to the 6 mm to the 4th. Therefore, the polar moment of inertia about point O IO equals 26.629 plus 59.8865 quantity times 10 to the 6. Then it is equal to 86.52 times 10 to the 6 mm to the 4th. Level 80 for the H-beam section, determine the flange width B, which will make the moments of inertia about the central X and Y axis equal. So we have here the H section, beam section. The condition is Ix equals Iy. So for our solution, let's set up the equation Ix equals Iy. So for Ix, we divide the areas into this middle rectangle and these two identical rectangles here. So for this middle rectangle, the x-axis happens to be the centroidal axis of this middle rectangle as well as for these wing rectangles. So the dimension here horizontally is 100 minus 2 times 10, so 80 mm. The height is 10, so 2 times, so it is 80 times 10 cube over 12 for this middle rectangle. And for these two, with respect to this x-axis, so it's also the centroidal axis, so 2 times 10 b cube, height is b, so b cube over 12. So Ix equals 80 times 10 cube over 12 plus 2 times quantity 10 times b cube over 12. Simplifying, Ix equals 6666.67 mm to the fourth plus 5/3 b cube mm to the fourth. So anyway, it's consistent. Iy, on the other hand, is moment of inertia of this middle rectangle is 80 cube times 10 over 12, while for these two rectangles, we have to transfer it, the moment of inertia with respect to that centroidal y-axis to here. So the distance of the centroid here to the y-axis is, because this is 100, half is 50, 50 minus 5, half of 10, so that's 45. So Iy is equal to 80 cube times 10 over 12. So Iy equals 80 cube times 10 over 12 for the middle rectangle plus 2 times 10 cube times b over 12 plus area of the rectangle 10b, then distance square 45 square, then times 2 because there are two vertical rectangles, these rectangles here. Simplifying, Iy equals 426666.67 plus 122,000 over 3 times b. Then equating 6666.67 plus 5/3 b cube equals 426,666.67 plus 122,000 over 3b. Then simplifying further, 5/3 b cube minus 122,000 over 3b minus 420,000 equals 0. Using your high-tech calculator and considering only the positive root, b is equal to 161.1 mm. Level 81, use numerical integration to compute the moments of inertia about the x and y axis for the symmetric region shown. So for our solution, we have to consider a strip as shown. So call that x, thickness, distance from x-axis y, and the thickness is dy as shown. So that, take note, it is symmetric with respect to this y-axis here. So we have a similar strip here, so we double that value. So differential Ix is distance square y square times differential area x dy. So 2 times then times 2 because of the other strip here. So 2 times distance square y square and differential area, which is x dy. So where dy is delta y, which is 20 in the Simpson's 1/3 rule. So differential Ix therefore is 2 times xy squared dy. So from Simpson's 1/3 rule, there is the formula for the area of the region by approximate integral, which is equal to d over 3 quantity h sub o plus 4 times summation of h add plus 2 times summation of h even plus h sub n. So remember from Simpson's 1/3 rule, d over 3 area is d over 3 quantity ho plus 4 times summation of h add plus 2 times summation of h even plus h sub n, where d is 20 mm here, this one, or delta y or dy in this case. Then there is that 3 there in the formula. Ho is this value, then our HO is this quantity here, xy square, where x is 20 and yo is 0 because this is the x-axis, so there's no distance. Yo is 0 here. Then this is 0, this is 1. So Ix is 2 times delta y over 3 from this equation, 2 times delta y, wherein delta y is dy, which is d, then over 3 in the formula. Then quantity HO plus 4 times summation of H add 2 times summation of H even plus H sub n. So again, this 3 here is this constant formula here from Simpson's 1/3 rule. So this HO is this expression here, this xy square here, where x is 20 and y is for yo is 0. Then this is 0, n is 0, this is n is 1. So add n is 2, even n is 3, add n is 4, even n is 5. Then this is the last h sub n. So that's x y square, where x is 77 and y there is 120 for that last numbering. So Ix, which is interpreted by this, and this is now the formula, is equal to 2 times 20 over 3 quantity 20 times 0 square plus 4 times quantity 22 times 20 square. This is add 35 times its distance from the x-axis 60, so 60 square. Then the other add is this one, 60. Its distance from the x-axis is 100 square. So that's the interpretation of 4 times summation of h add this whole quantity here, xy square. Then 2 times summation of h even. So these are even values. So 27 times distance 40 square. So 2 times quantity 27 times 40 square. X is 27. Then y is 40. Then quantity square. Then the other even here, excluding this because this is the last, is 46. And its distance from the x-axis is 80 quantity square. So 2 times sa summation of xy square, which is even. Then plus x hn, which is xy square for the last is 77, that's the x, and its distance from the x-axis is 120 quantity square. So computing Ix is equal to 62.976 times 10 to the 6 mm to the fourth. Likewise, with respect to the y-axis, the moment of inertia of this element is 1/3. Remember, 1/3 rectangle with respect to the base, 1/3 x cubed dy. So diy is 1/3 x cubed dy. Then we multiply it by 2 for this other strip here on the left. So times 2. Then differential iy therefore is 2/3 dy times x cubed, where dy is delta y, or d in the Simpson's 1/3 rule. But because there is this 1/3 here, we multiply this by the, we multiply this further by 1/3. So iy equals 1/3 of quantity 2/3 delta y, dy is delta y, then summation of x cubed. So the expression is only x cubed for this HO, H odd, and H even, and Hn. So simplifying, iy equals 2 delta y over 9 summation of x cubed, where delta y is 20 and x would be these values here. So iy equals 2 times 20 over 9, then quantity 20 cubed plus 4 times h add, so 22 cubed, 30 plus 35 cubed plus 60 cubed, then 2 times x cubed even, so 2 times quantity 27 cubed, that one, and the other even value before the last is 46 cubed, then plus hn, which is summation of x cubed, is 77 cubed. So computing iy is equal to 7.896 times 10 to the 6 mm to the fourth. So we will have another approximate method on the next slide so that we can compare these values here and we can verify if they are really uh, correct. These values are correct. Level 82, this is from level 81 problem, but I presented a solution which is different from the solution in 81. And let's compare the results. Compute approximately the moments of inertia about the x and y axis for the symmetric region shown by introducing median lines such that the distance between lines is 10 mm. So instead of 20, to accurately approximate the moment of inertia with respect to the x and the y axis, we have to introduce median lines so that the distance between those lines would be 10 mm instead of 20 mm to make it more accurate. So for our solution, the length here is 20 times 2, so 40 mm. So the median line here, because this is 44, so the median line here is 42. So that's 42 times 2 of 21. The average of 20 and 22 is 21 times 2, so 42 mm. Then this is supposedly 44, 22 times 2, and this is 27 times 2, 54. So 44 plus 54 is 98 divided by 2, so 49. So simply we just add this because we multiply the length here or the median line by 2. So it's just 22 plus 27, so 49. 27 plus 37 divided by 2, then times 2, so that's the length here. So it is 62. Then 37 plus 46 divided by 2 times 2, so 81, the median line, length of this median line. Then 46 plus 60 divided by 2 times 2, so that's 106, the length of the median line here. 60 plus 77 divided by 2 times 2, so that's 137 here. So therefore, the area here of this rectangle is equal to approximate area is median line, average of 40 and 42 is 41 times 10, because this is now 10 mm and we treat this as a rectangle. So for 41 times 10 is 410. The area here is 410 mm square. Then 42, this is 44. This is 44. 22 times 2 plus 42, so 43 times 10, so 430, the area here. 44 and 49 is 93 divided by 2, 46.5 times 10, so this is 465 mm square. 49 and 54 divided by 2 times 10, so the area here is 515 mm square. Then 54 plus 62, 54 is 27 times 2 plus 62. Then divide by 2 times 10. Then the area here is 580. So meaning to say 54 plus 62 is 116 divided by 2, 58. So that's why 58 times 10 is 580. 62 plus 70, 132 divided by 2, 66 times 10, so 660 mm square. 70 and 81 divided by 2 times 10, so the area is 755 mm square. 81 plus 46 times 2, so 92. 81 plus 92 divided by 2 times 10, the area here is 865. 92 plus 106, 198 divided by 2, 99 times 10, so 990 mm square. Then 106 plus 60 times 2, 120, 126, 226 rather, divided by 2, 113 times 10, 1130. Then 120 and 137 divided by 2 times 10, so that's 1285, the area of this entire rectangular strip, which is approximated rectangular strip. Then 137 plus 154, because 77 times 2 is 154, divided by 2 times 10, the area is 1455 mm square. So Ix is from formula, Ix is equal to distance square times area, differential area. So summation of distance square, which is y square, times delta A, where y is for this rectangle here with thickness 10 mm. So y is the distance from x-axis to the centroid of that rectangle is 5. Then for the next rectangle, it's 10 plus 5, so 15. So the distance is increased by 10 as we move on, beginning with 5 up to here. So since this is 120, so the last y for this last area is 115, 120 minus 5. Then delta A would be these areas here. So that's our guide. So Ix is, again, the distance of the first lowermost rectangle. The distance of each centroid from the x-axis is 5 mm, half of 10, because this is 10 mm. Then the area is 410. For the next area, this 430 here, the distance from the x-axis is 15. So 15 square, 10 times area 430, because remember, moment of inertia is, differential moment of inertia is distance square times differential area when the strip is parallel to the axis. So distance square times differential area. So plus 15 square times 430. Next is plus 25 square times 465 plus 35 square times 515 plus 45 square. The distance here is 45. This one, the centroid, 45 square times 580. The next is 55 square times 660. Next is 65 square times 755. Next is 75 square times 865. Then 85 square times 990. 95 square plus 95 square times 1130 plus 105 square times 1285. Then lastly plus 115 square times 1455. So combining these values, Ix is equal to 63.02 times 10 to the 6 mm to the fourth, and comparing it with the answer in level 81, it's close. So that means this is also an approximate uh, method of computing this moment of inertia. Likewise, for Iy, so Iy is summation of 112 x cubed delta y. So remember, if we have a rectangle here, the moment of inertia with respect to the y-axis, which happens to be the centroidal axis also of the rectangle, is base cube, wherein 112 or base cube, the base is x, these red values here, and intermediate values not shown. Then delta y, where delta y is 10. This delta y is 10. So uh, remember, moment of inertia of rectangle with respect to the centroid is 112 times, because with respect to the y-axis, so we have to cube the base, which is x in this case, and delta y is the height or the thickness, which is 10. So this x here will begin with the average of 40 and 42, which is 41. So 41 cube. Then the average of 42 and 44 is 43. So you just imagine that these areas are divided by 10. So the x here would be 41, 43, 46.5, 51.5, 58, 66, 75.5, 86.5, 99, 113, 128.5, and 145.5. That should be cube. Delta y is 10. So Iy equals 10, delta y is 10 over 12, then x cube. So beginning with 41 cube. So again, that 41 is 410 divided by 2, the mid length of x here between 40 and 42, which is 41, of course. So the shortcut is we just divide this by 10, these areas here. So the next value is 430 divided by 10, so 43. So 43 cube, then 46.5 cube, 51.5 cube, 58 cube, 66 cube, 75.5 cube, plus 86.5 cube, plus 99 cube, plus 113 cube, plus 128.5 cube, plus 145.5 cube, and that's the end. So computing this Iy equals 7.968 times 10 to the 6 mm to the fourth, which is very also close to the answer to level 81 problem.